signals and systems. The first problem, it has appeared in GATE 2007, is the Laplace transform of a signal yt is given. Signal yt is ys equal to 1 upon s into s minus 1. Okay. Then the final value of yt is asked. Of yt is question mark. 4 options were given, but we'll see how to solve this. Okay. See, ys is given as 1 upon s into s minus 1. From this, if we find yt, then I need to partial fraction this. Okay. Or it will be minus sign here, plus sign here. Okay. So I will get 1 upon s minus 1 minus 1 upon s. Okay. Taking the inverse Laplace transform of this, I will get yt is equal to e to the power t minus ut. This is also multiplied by ut. Okay. So by looking at this expression, I can easily find y infinity will become e to the power infinity, which is unbounded. Okay. So this option as an unbounded was one of this answer as an unbounded was one of the option in the question. Okay. Understood? A simple question. Very easy. Nothing. No. Not required to use any formulas. Just find the inverse Laplace transform of the given Laplace transform and put the value of t as infinity and get the answer. Okay. Next question is finding the, okay, the statement of the question is find the 3 dB bandwidth for low pass signal xt equals to e to the power minus t ut. Okay. See how to solve this. Now 3 dB bandwidth is the bandwidth at which power becomes half. Okay. So representing this xt in frequency domain, this will be x of j omega minus infinity to infinity xt to the power minus j omega t dt. Solving this, 0 to infinity e to the power minus t e to the power minus j omega t dt. Now we are doing nothing, just we are finding the Fourier transform. If we can easily find, or if we remember the Fourier transform of this directly we can write this expression. Okay. That is equal to 1 by j omega plus 1. Okay. Now, for finding 3 dB bandwidth, my x of j omega modulus should be 1 by root 2. Because power is 1 by 2, so this will become 1 by root 2. So 1 by root 2 equals to 1 by j omega plus 1 mod. Okay. So I can write 1 by under root of omega square plus 1 equal to 1 by root 2. This implies that omega is equal to 1, or 2 pi f equal to 1, f equal to 1 by 2 pi hertz. Okay, so this is the answer for this problem. Okay, the 1 by 2 pi was one of the options given in the question. Another problem. The frequency response of a linear time invariant system is given by HF equal to 5 plus 1 plus J 10 pi F. For this particular frequency response, we have to find the step response. This problem has also appeared in GATE 2007. How to solve this? Again, it is simple. If we find the inverse, see, HF is written like this, 5 upon 1 plus J 10 pi F. I can write HF also like this, 2 pi F. This will become 1 upon 1 by 5 plus J omega H of omega. Okay. Now for this I can find the inverse Fourier transform. Okay. On finding the inverse Fourier transform, I will get HT, and that HT is nothing but the impulse response of the system. Now to get the step response, we need to integrate the impulse response. Okay. Now we can find the impulse response of this, which is equal to e to the power minus 1 by 5 t ut. Okay. More correctly, e to the power minus 1 by 5 ut. Okay. Finding the step response from this, I need to integrate this from 0 to t, 0 to t e to the power minus 1 by 5 tau d tau. Okay. I will get minus 5 e to the power minus 1 by 5 tau 0 to t. Substituting, I will get minus 5 e to the power minus 1 by 5 t minus 1. So the answer is 5 times of 1 minus e to the power minus 1 by 5 t. This is the step response for the given magnitude response of a linear time invariant system. Understood? First we have to find the impulse response. After finding the impulse response, we can find a step response just by integrating this. Suppose if a step response is given and we want to find the impulse response, we need to differentiate the step response. Okay, so they are just the integral differential relationship between impulse response and step response. Now suppose if a question comes to find the ramp response is integral of step response. Okay, and from the ramp response, if we want to get the step response, again we have to differentiate the ramp response, we can get the step response. So they all are just related by integral differential equations. Okay. Again, one more question. This question is quite interesting, and it just uses the very simple concept. Okay, a 5-point sequence of xn is given. given, that is given as x of minus 3 equal to 1, x of minus 2, that is also equal to 1, x of minus 1 equal to 0, x of 0 equal to 5, x of 1 equal to 1. Okay. Now for the sequence xn, assume that x of e to the power j omega is a discrete Fourier transform. Discrete Fourier transform of xn. Okay. Then we need to find now the question is, find the value of minus pi to pi x e to the power j omega d omega. Okay. See, very simple solution. We know from the synthesis equation of discrete time Fourier transform, xn equal to 1 upon 2 pi minus pi to pi x of e to the power j omega dot e to the power j omega n d omega. Okay. Now compare this equation with the equation given in the question. The difference between these two equations is e to the power j omega n term is not there. When this term will be not there? When n equal to 0. So if I substitute n equal to 0 in this equation, I will get x of 0 is equal to 1 by 2 pi minus pi to pi x of e to the power j omega d omega. Okay, substituting n equal to 0. Now I can write from the previous equation minus pi to pi x of e j omega equal to 2 pi x of 0. Now x of 0 from the question is 5, so it will be 2 pi into 5 equal to 10 pi. Thus 10 pi is the answer for the question. Okay, 10 pi was one of the choices in the option. Okay, so very simple problem. Okay, understood? There is no mathematical big formulas. Just the equation for the synthesis equation in DTFT gives me the answer. Now one mark problem which has appeared in GATE 2006 paper, and that is, this is problem number 6. A low pass filter frequency response is given. J omega e to the power j phi omega. And this frequency response is given and asked, among the choices, it will not produce any phase distortion, does not produce any phase distortion if, first, 4 options are given now. J omega equal to C omega square, phi omega equal to Q omega cube. Option B is A of omega is C omega square, phi of omega equal to Q omega, A of omega equal to C omega, last is A of omega equal to C. In this the phase condition is phi of omega Q omega square. In this the phase condition is phi of omega Q omega max. Now what is required so that there must be no phase distortion? Okay, only thing is that it becomes very simple. First of all, A of omega can be anything. It will have no effect on the phase distortion. It will have effect only on the magnitude spectrum. No effect on phase spectrum. Okay, phase distortion and distortion is nowhere related to A of omega. The only thing is related to omega is phi of omega, that is the phase function, and for no distortion case phi of omega must be linear. For no phase distortion, phi of omega must be linear. Okay, so phi of omega is linear only in option B. Thus option B is the right answer. Okay, see, in the option B it is phi of omega equal to k of omega, k into omega. So in option A it is k omega cube, in option C it is k omega square, in option D it is k omega minus 1. Because if phi of omega is linear, that means it is k omega, that means the group delay, which is the differential of phase function phi omega, will be a constant. Okay, so for no phase distortion, group delay must be constant. This was a 1 mark question, appeared in GATE 2006 paper. As a problem from GATE 2006, let xt be the and xt and x of j omega be the Fourier transform pair. Okay, now we have to find the Fourier transform for Fourier transform for x of 5t minus 3 in terms of x of j omega. See, when I am writing xt from, means converting xt to x of 5t minus 3, I have to be careful what operation to be done first. Okay, to convert xt to x of 5t minus 3, I need to shift xt by 3 first. Okay, so the first step will be x of t minus 3. Then scale this by 5 times, x of 5t minus 3. Okay, similar operation will have effect on the x of j omega. We have to shift the shifting property, then we have to use the scaling property. So on shifting property, if xt is having Fourier transform x of j omega, then x of t minus 3 will have e to the power minus j 3 omega x of j omega. Okay, x of 5t minus 3, that means time scaling, will have Fourier transform e to the power minus j 3 omega by 5 x of j omega by 3. Okay, so this is the answer. So there was one option which satisfies this answer. Okay, again one more problem from the same 2006 GATE exam. Region of convergence for two sequence x1n plus x2n is given, and that region of convergence is 1 by 3 less than mod set less than 2 by 3. Okay, then they ask to find the region of convergence for x1 of n minus x2 of n. Is very simple. Region of convergence will not change. It is remain same as 1 by 3 mod z less than 2 by 3. Okay. No change in region of convergence. Okay. Region of convergence will remain same until and unless there is no pole zero cancellation. But that thing is not mentioned in this. So that's why there will be no change in region of convergence. It will remain same. Now one more very good problem appeared in GATE 2006. Okay. A signal GT is given as a convolution of signal PT with PT. Okay. This is signal GT. Signal PT is given as u of t minus u of t minus 1. Now, we need to find the impulse response of filter match to the signal. That means we want to find the impulse response of a matched filter. So this question becomes a part of communication as well as signals and system. Convolve with GT. Okay. GT is given as PT convolve with PT. First line. PT is given by ut minus e of t minus 1, where ut is a step function. Now we have to find the impulse response of a filter matched to signal st. Now signal st is defined by gt minus delta of t minus 2 into gt. Okay. So there are various steps involved in this. So we will find the solution. First of all, what is PT? PT signal is u of t minus u of t minus 1. Okay. So this is on drawing will become 0 to 1. This is my PT. Now GT is PT convolve with PT. So this will become, when I convolve rectangular with a rectangular pulse, it will be a triangular pulse. The range will be from 0, 1 and 2. Okay, this is my GT. Delta of t minus 2 convolve with GT will be this. Delta of g minus 2. Delta of g minus 2 means I will have GT shifted by t minus 2 is equal to g of t minus 2. Remember the shifting property. Shifting property. It will become like this. 2 to 4. This is 3. Okay. Now what is ST? ST is given by GT minus delta of t minus 2 convolve with GT. So if I draw ST now, it will be somewhere like this. Zero, 2 and 4. Okay, this is my ST. Now I have got ST. Now what is the match filter response? Okay, this is the impulse response for the signal ST. Now the match filter response, you will see. Match filter response will be S of 4 minus t. Generally, it is h of t minus t, where t is the time, total time within where it spans. Okay, so from st to s of 4 minus t, I will have like this. First there will be a shift of 4. My this is s of t plus 4. From s of t plus 4 to s of minus t plus 4, that will be the reversal of this. So I'll get that something like this. Okay, 0 and 4 and 2. This is my s of 4 minus t. This s of 4 minus t is also equal to minus of st. This is the impulse response of the match filter, which is one of the options in the question. Okay. One more question. Just we have to input output relationship is given, yn equal to sine 5 by 6 pi n xn. We have to see whether the given system is linear or non-linear, stable or unstable, invertible or non-invertible. Solution. System is linear. If xn is bounded, definitely yn is also become bounded. That means it is stable and it is non-invertible. Why it is linear? Because yn and xn are related by only single power. Okay. System is time variant. Okay. This is linear time variant. It is not time invariant system because xn and yn are related by a function of time, and that is sine 5 by 6 pi n. Okay. So this was one more, and this was 2 marks problem asked in GATE 2006 paper. One more question, again asked in GATE 2006. Find the minimum sampling rate of signal xt, which is given by xt equal to 5 sine 2 pi 1000 t by pi t whole cube plus 7 times of sine 2 pi 1000 t by pi t whole square. So this is a combination of two signals. Okay, we have to find the minimum sampling rate. Okay. Solution. For any signal xt equals to sine 80 by pi t, f max is equal to, that means a by 2 pi. Okay, this is the frequency max present in this. How this I got? This I got using duality principle. If time domain sequence rectangular pulse can have sync, then sync can be of rectangular. Okay. Now sync in time, rectangular in time domain is sync in frequency domain. Okay. Vice versa is also true. Sync in time domain is rectangular in frequency domain. So these points, these are the band limited signals. Okay. For this band limited signal, frequency max is a by 2 pi hertz. Okay. So I got a by 2 pi. Now in the question it is given sine 2 pi 1000 t by pi t whole cube. That means I am multiplying the signal 3 times. Multiplication in time domain goes to convolution in frequency domain. One more principle is involved. Multiplication in time domain becomes convolution in frequency domain. Now once the convolution takes place in frequency domain, the frequency will get added up. So it will become, now the frequency first f max in sine 2 pi 1000 t by pi t is 1000 hertz. Okay. So f max in multiplication of this, in cube of this, will be 3000 hertz. Similarly, you can write here f max in sine 2 pi 1000 t by pi t whole cube is 3000 hertz. Similarly, the second term is also there. Second term, again the frequency present there will be 2000 hertz. So the maximum frequency present there is 3000 hertz. So minimum sampling rate is equal to 2 into 3000 equal to 6000 hertz. So 6000 hertz was one of the options given in the question. Okay, so this was one typical problem asked in GATE 2006. One more question from GATE 2005 paper. This will be question number 13. I may be wrong in numbering these questions, but anyways. This question is related with Z transform and we have to find the region of convergence. Find the region of convergence of Z transform of the sequence 5 by 6 to the power n un minus 6 by 5 to the power n un, u of minus n minus 1. Okay, so we can solve this problem in part. For the sequence 5 by 6 to the power n un, region of convergence mod z must be greater than 5 by 6. For the sequence minus 6 by 5 to the power n u of minus n minus 1, mod z must be less than 6 by 5. Okay, now we can use the linearity principle and we can add up these two sequences. The region of convergence will be the intersected region. Okay, so in this, if this is a unit circle, for one region of convergence is this, for this is my unit circle. 5 by 6 will lie inside the unit circle, 6 by 5 will lie outside the unit circle, and for other I have inside. Okay, so the common region is lying between these two. And that region is 5 by 6 mod z less than 6 by 5. That is the region of convergence. Okay. One more question, again from the same GATE 2005 paper. Which of the following signal will not have Fourier series? Now for condition for Fourier series is that a signal must be a periodic signal. So first signal given here is 3 sine 25t. Yes, this is a periodic signal. Second one is 4 cos 20t plus 3 2 sine 10t. This is also periodic signal. Third one is exponential of minus mod t sine 25t. This is not a periodic signal. Third one is d is a constant. D is equal to 1. That is a constant. That is again a periodic signal. So out of these three, only C option is there which is not periodic. So the C option will not have Fourier series for this. Other definitely will have Fourier series. Okay. So and only thing is that we should see whichever is periodic. If it is periodic, it may possess a Fourier series. If it is not periodic, it will not possess Fourier series, but it will have Fourier transform. Okay. One more problem. Again, this appeared in GATE 2005. The sequence xn is given as 1 by 2 to the power n un. Okay. Another sequence yn is given as x square n. It is also given that y e to the power j omega is the Fourier transform for yn. Okay. Then the question is find the value of y e to the power j. Question mark. Solution. See, yn equal to x square n. So this will be 1 by 2 to the power n whole square un. This will be how much? 1 by 4 to the power n. Okay. Now y of e to the power j omega is equal to summation k tending to minus infinity to infinity yn e to the power minus j omega n. Okay. So writing this k tending to 0 to infinity, sorry, not k, this is n tending to 0 to infinity 1 by 4 to the power n e to the power minus j omega n. This is my y of e to the power j omega. Now question is to find y of e to the power j0. That means omega equal to 0. If I substitute omega equal to 0 in this equation, it will become summation n tending to 0 to infinity 1 by 4 to the power n dot 1, because this term will become equal to 1. So it is nothing but summation of a geometric sequence. So this will be 1 upon 1 minus 1 by 4 is equal to 4 by 3. So 4 by 3 is the answer for this, and 4 by 3 was one of the choices in the question. Okay. With this we complete one set of problems from signals and system topic which have appeared in GATE 2005, 2006 and 2007 papers. Okay. We will see one more set of similar problems appeared in previous GATE exams.